Hello and welcome to Maths with Lloydie. Question number 5. Sponsors are there. Can you guess who the sponsors are? There they are, Grays Hockey. Okay, question number 5. A balloon is being inflated for 5 seconds. Assume that the balloon is a sphere. Sam investigates how the radius of the balloon changes with time as the balloon is inflated. He plots the points on the graph below. Use the graph to estimate the rate at which the radius is increasing at time t. So I'm just going to, with a red pen, just sketch through that. Then I'm going to use a ruler and this purple, I want to say purple. So I want to get this right. There we are, that looks good to me. And I've drawn my tangent to that line. Now with my tangent, I should be able to now estimate the rate. Finding a coordinate is going to be the challenge. Oh, there's one 0.2. And that's 1.6. That's one coordinate that we've got. And then another coordinate, I don't want to be too, there we are, that's one there. So that's 5.4 to what looks like 3.4. Okay, change in y. 3.4 take away 1.6 divided by the change in x, 5.4 take away 0.2. I'm not making any mistakes here. Calculator. 3.4 take 1.6, it's probably 1.8. It is 1.8 over 5.2. 1.8 divided by 5.2 gives me 0.34615. So my answer here, is it asking for anything? No, we're going to go with 0.346. Now I've done this on paper and I've just done it on the screen and I've got two totally different answers, which is very, very normal. When I look at the mark scheme, of course, because not everybody's going to draw the same diagram, will have a tolerance. And it's saying anywhere between 0.3 and 0.45, which I think is more than reasonable. Okay, part B. Describe how the rate of change of the radius varies during the first 5 seconds. So as time goes on, the increase is decreasing. The rate of change is increasing. So as time goes on, the rate of change is decreasing. Okay, part B. This is very plug and play. So we've got to put this into our calculator. 2.19 cubed times by pi times by 4 over 3 is 43.99. So that's 44. I can't believe this is 3 marks. 2.72 to the power of 3 times by pi times by 4 over 3. 84.29, which is therefore 84. Okay, I mean, that is 3 relatively nice marks. That's quite comfortable. Right, part D over the page. Work out the rate at which the volume of the balloon is increasing. State the units of your answer. So 44 take away 4. So it appears to be changing at a constant rate. 44 take away 4, that'd be the volume, over 2 is equal to 20 centimeters cubed per second. Now, if I take a look at the other areas, I mean, again, it's the same. 84 take away 44 over 2 is 40. Some of you, over 2, which is 20. Some of you may be saying, where's the 2 come from? So it's the difference between 2 and the 0. For the other one, the difference between 2 and the 4. So that's the difference in time. And our units are centimeters cubed per second. Okay, the initial volume of another balloon is 4 centimeters cubed. It starts to be inflated when t is equal to 1. Its volume increases at a constant rate of 30 centimeters cubed each second. Work out the non-zero time when the two balloons have the same volume. Okay, it says you can use the grid if you wish. That probably means drawing a graph, and this is the graphy kind of unit, but I'm not doing that. I'm going for an equation. So the new volume, or the volume of what we've just been told, it starts at 4, and then it's going to increase, which means it has a gradient of 30 from t minus 1. Okay, so when t is 1, the balloon's volume is 4. So 1 minus 1 would be 0, giving us the volume is 4. And then it'll increase by 30 as we go. Now that's going to be equal to the other one. So we start off with a volume of 4 for the other one. And then it's just going up by 20 every time. Now we can start to solve this. That cancels there. Expand that left-hand side, 30t, take away 30 is equal to 20t. 10t is going to be equal to 30, and therefore t is equal to 3. So t is going to be 3 seconds. Okay, is there a part F? Can't remember. Scroll down for me. No, so we're on to question 6 next. Thank you very much for your support, and I'll see you at the next question.